So we need an example for the sampling distribution of means and how it ties into a joint distribution. So here it is. The kids came up with, I asked for a topic, we said, well, let's talk about hippos and their hip, and so they're disco dancing. So we said, okay, well then the lengths of time that hippos can disco dance, normally distributed with a mean of 48 minutes, standard deviation of 6 minutes. There is the normal distribution showing the possible times, one hippo at a time. We had to come up with some puns like, they love to do the bump, but hippos kill 10,000 people a year because they crush people and they do the bump. So when they're out on the dance floor, we're going to see, you guys are killing me. And then they thought the disco ball was edible. So I said, did you have fun? Oh yeah, we had a ball. But anyways, so then we got over here and we said, okay, well, let's say we randomly sample 8 hippos. And then we want to find that probably the sum of their times exceeds 400 minutes. So this is a joint distribution. We add 8 of the times together. You can see they're normally distributed. We take the square root of the sum of the variances and all that good stuff. So there's our distribution for the sum of times. Normally distributed mean of 384 minutes, standard deviation 16.97. There then is the joint distribution, and we're trying to find the probability of getting over 400. We show the work and we get 7.1729 as our probability. Well, now again, let's go back and do an equivalent problem. We take a random sample of 8 hippos, but we want to find the probability that the mean is greater than 50 minutes. So we do the mean and the standard deviation for these guys, and we get that right there. We go down to this little tiny distribution, and lo and behold, we get the same answer. Actually, the probabilities aren't exactly the same, but that's just due to rounding error. 0.1729 and 0.1727. But now here's the deal. Why are they equivalent? Well, let's go back. If you remember from algebra, solving systems of equations, how many solutions to that system? Well, if you pay close attention, the second equation is just the first equation multiplied by 3. So they're really the same equation. Well, that's what's happening here. If we start with the joint distribution, but we divide the sum by 8 to get the mean, and therefore we divide the sum of 400 by 8 to get a mean of 50, then we can see this is an equivalent problem. Find the probability that the mean is greater than 50 minutes. So they're really the same problem. It's just that we're taking a mean average as opposed to just using the sum. And then one more thing, how is this sampling distribution related to the original one, the original population distribution? Well, one hippo at a time, if you look at those little red X's, those would be like a sample of 8 from the population. So those are different hippo times. We would add those 8 times and divide by 8 to get a mean average, and then the sample means would be distributed according to that blue distribution, because there's a whole lot less variance when you take the sum of 8 numbers and divide it by 8 to get an overall mean average. So that's why the sampling distribution of means is much less spread out. How much less spread out? Well, you take the standard deviation of 6 and you divide it by the square root of the sample size, and that is the standard deviation. That's how spread out the sample means would be in comparison to the original times of the hippos.